Welcome back. In the last video we talked a lot about complex numbers, and we said that in general a complex number z will have the form a plus b times I, where a and b are just constants. Now, what you're going to need to do a lot of the time is try and figure out what the real part of the complex number is and what the imaginary part of a complex number is. And typically they might ask you that in a shorthand notation, like they might ask you to find the real part of z and the imaginary part of z, using this notation here. Now if something is already in standard form, then finding the real part and the imaginary part is easy. In this case, the real part is just a, and the imaginary part is just b. And we stressed in the last video that although bi is the imaginary number, it's just this constant b, which is the imaginary part. We don't include the I term. So, if you have a nice simple complex number like z is equal to 4 minus 9i, in that case finding the real and the imaginary part is easy. The real part of this complex number is just 4. The imaginary part of this complex number is just minus 9. But occasionally it won't be this nice and simple. Occasionally you might see complex numbers as really messy expressions. And what we're going to need to do is just simplify them down to this standard form in order to really easily find out what the real and the imaginary parts are. So that's what we're going to do in this video. We're just going to do a bunch of examples trying to find out what the real and imaginary parts are for relatively intimidating looking complex numbers. So let's start off. Let's just say, for example 1, let's say that our complex number z is equal to 1 plus I squared. Before we find out what the real and the imaginary part is, let's try and reduce it down to this standard form. And let's first do out the square, so that's 1 plus I times 1 plus I, and we can just distribute this out. That's going to be equal to 1 plus I plus I plus I squared. And we know that I squared is equal to negative 1, so we can rewrite this as 1 plus 2i plus negative 1. And in this case, the 1 cancels with a negative 1, so this whole entire thing reduces down to 2i. So the real part of this expression is just the real part of our complex number. That's just equal to 0. And our imaginary part of our complex number, that's just equal to 2. And it's really important to try and simplify it down to the standard form, because you wouldn't necessarily guess that just by looking at this expression here. Now let's move on to the next example. Let's say that we have z is equal to 1 over 1 plus I. Here the complex term is in the denominator. Once in the denominator, it isn't really intuitive what the real and the imaginary parts might be. So we're going to try and rearrange this into a more helpful form. So what we're going to try and do is we're going to try and get rid of the complex part in the denominator by multiplying by its conjugate, 1 minus I. And in order to make sure we don't change the actual function, we're going to have to multiply the numerator by the same amount. That way we could say we're just multiplying it by 1. Basically a fraction is the same thing in the numerator and then the denominator, that's just 1. So we're not actually changing the expression, we're just rewriting it. So multiplying out the numerator, we're just left with 1 minus I on top. And multiplying out the denominator, we get 1 plus I minus I squared. And the plus I and the minus I will cancel, and this minus I squared, that's just minus negative 1, which is just equal to 1. So this whole thing reduces down to 1 minus I all over 2. Just 1 plus positive 1. So just to really hammer this out, we can rewrite it as our complex number z is equal to 1/2 minus 1/2 I, in which case it's really simple to see that the real part of this is just 1/2, and the imaginary part of this is just negative 1/2. So that wasn't too bad. Now let's just take a look at one last example. Let's try and see what is the most simplistic form if our complex number is I to the third power. Now, we know that I squared is equal to negative 1. So we can try and say that I to the third power, that's the same as I squared times I, which is just negative 1 times I, which is just negative I. And an interesting thing happens if you look at I raised to greater powers. Let's see what happens if we look at I to the fourth. That's just I squared times I squared, which is just negative 1 times negative 1, which is just equal to 1. And we can even do I to the fifth. That's just I squared times I squared times I, which is negative 1 times negative 1 times I, which is just equal to I. So an interesting pattern emerges when you look at I to different powers. And let's just write that out. We can immediately start off by saying that I to the 0 power is just 1, because anything raised to the 0 power is just 1. I to the first power, that's just I. It's fairly obvious. We know that I squared is negative 1. We just found out that I cubed is equal to negative I. I to the fourth is equal to 1. I to the fifth is equal to I. And then the pattern repeats. It's a nice little pattern of 1, I, minus 1, minus I. So this is a fairly handy thing to keep in mind whenever you're trying to simplify complex numbers. It's just seeing if you can reduce a crazy power of I to a more simplistic form. And with that, I'll hopefully see you in the next video.